Kepler-88d has a mass 3 times that of Jupiter. This newly discovered giant orbits its Sun-like star every 4 years and may have played a role in the emergence of life on neighboring rocky planets. According to a recent study, astronomers have reported that Kepler-88c, an outer gas giant orbiting a Sun-like star known as Kepler-88, is no longer the largest planet in the Kepler-88 star system and that its dominance over the planets of the system has passed after they confirmed the discovery. A new gaseous planet that is more massive than it in the same star system, with a mass 3 times that of Jupiter. The research, conducted by a team of astronomers at the University of Hawaii's Institute for Astronomy based on data collected over 6 years using the W.M. Keck telescope located on the top of Mount Mauna Kea in Hawaii, revealed the presence of a third exoplanet orbiting the star Kepler-88, and scientists have reported that this new planet, which they called Kepler-88d, slowly orbits its star, completing one cycle every 4 years. Lauren Weiss, principal investigator of this study and a postdoctoral fellow in the Beatrice Watson Burnett Fellowship Program at the University of Hawaii's Institute of Astronomy, reported that her science team was able to detect the presence of this new planet thanks to its use of the high-resolution Eickel spectrometer instrument. The Eickel spectrometer HIRES on the 10-meter Keck 1 telescope called the discovery astonishing and unprecedented. Kepler-88d has 3 times the mass of Jupiter, so this new giant likely played a larger role in the genesis of the Kepler-88 star system than its competitor, Kepler-88c, which was once more massive than Jupiter, Weiss said. Simply put, Kepler-88d has emerged as the new hegemon of this star system. It is noteworthy that the star system Kepler-88, located in the constellation Lyra at a distance of more than 1,200 light-years from Earth, has drawn the attention of astronomers greatly and prompted them to intensify monitoring and observation efforts after they discovered the first 2 exoplanets in it, Kepler-88c and Kepler-88. In 2013, the astronomical observations carried out by scientists at the time revealed that these 2 planets interact with each other in a remarkable way. Scientists at the Keck Observatory have observed that Kepler-88b, which is classified as an exoplanet smaller than Neptune, completes one orbit around its star every 11 days. That is, it takes half the time of Kepler-88c to complete one cycle. They also reported that Kepler-88c, which orbits in an outer orbit around its star, has a mass that exceeds that of Kepler-88b by about 20 times, which gives it a huge gravitational force that allows it to greatly influence the orbit of Kepler-88b, especially when the 2 planets come close to each other in their orbits around the star. The strange and remarkable interaction that astronomers have observed in this star system is called the mean motion oscillation, where the 2 planets affect each other in a balanced and accurate way. Weiss and her science team report that the motion of these 2 planets is very energy efficient, much like the motion produced by an adult pushing a child on a swing. Scientists used NASA's Kepler Space Telescope, which was officially retired on October 30, 2018 after running out of fuel, to accurately time the planets of the Kepler-88 star system in their orbits around the star Kepler-88. It is noteworthy that scientists relied on the transit monitoring technique, which is one of the techniques used to monitor the movement of exoplanets during their transit in front of the host star, that is, the star around which these planets revolve, in order to record scientific readings known as variations in the timing of transit. Although such anomalies in the timing of transits have been observed previously in many other planetary systems, the transit anomalies in the Kepler-88 star system are the highest to date. Scientists have noticed that some planets in the Kepler-88 star system pass in front of the star up to half a day before or after the expected time, which prompted them to describe this system as the master of transit anomalies. Jupiter, on the other hand, dominates all of our solar system's planets and has a clear influence on them due to its enormous mass, which exceeds the mass of Saturn twice and the mass of Earth about 300 times. Thus, the slightest movement of it greatly affects the rest of the celestial bodies in our solar system, including Mars, and the group of asteroids located between Jupiter and Mars, which scientists believe played a major role in bringing. Weiss says that this is exactly what interests the team of researchers in the Kepler-88 star system. They seek to find out if the planet Kepler-88d has a direct effect on water-bearing comets and if it actually contributes to pushing these comets towards the newly formed